So this is how to put the balance together. You get your ruler and nail and cork. And put the nail through center hole in the ruler and into the cork. The cork's got a hole. Put that nail right into the hole. And there it is. And these holes should be on the bottom. And then you get your piece of duct tape. About that long. Hang this over the edge. Actually, you could start it like this. Hang it over the edge. Make sure it's over the edge. The ruler won't touch the table. And tape it down. That's it. You can add more tape if you want onto the table. And there it is. Now you get 3 cups, or just 2 cups. Later, get these paper clips unfolded once, so it looks like that. And then poke one side through the cup, and the other side hangs on the ruler. But you want it hanging opens forward. Do that again. Good. And there they are, hanging nicely. Now the final paper clip is, well, now you can push the thing in a little bit more to stabilize it. And now if it's up a little bit on one side, you put the paper clip on that side. It's called the 0. Till it's perfectly straight back and forth. Not just straight, level. All right, then you're ready to go. The first thing you could do is, well, you've got these little trays. You can hand out the stuff in the trays however you want. You can put some stuff in one tray and more stuff in the other tray. But every kid should have some beans and some pennies, about 3 pennies. So one thing you can do, for instance, is to put a penny in one side and see how many beans it takes to weigh the same as a penny. 1, 2, 3, 4, 5, 6, 7, 8. Well, it's between 7 and 8. It's like 7.5 beans to make 1 penny. So you take one out again. Seven beans. Maybe it doesn't come out even, so you can't say there's exactly 7 beans in a penny. So then you can measure other coins. You can get anything around the room you want. Oh, and then you want to write all this down. Little notebook to write that down. So that was 1 penny equals 7 beans. Or you could say almost equals, with the wiggly equal sign, almost, approximately equal to 7 beans. Okay, and then you can measure other stuff. For example, the styrofoam is interesting. You could put a bunch of styrofoam in one side. No, you could put, for example, you put 1 bean in one side, and then you put styrofoam in the other side until it weighs the same as the bean. There's big pieces of styrofoam and little pieces of styrofoam. And you can also always hypothesize before you start how many pieces of styrofoam are going to weigh the same as the bean. And every now and then you want to kind of hit it to make sure it's not stuck. It's not like super accurate scale, but pretty good, it's not bad. So there you got it. And you, of course, you can't quantize that much styrofoam, but it's pretty interesting then if you take it and you dump it out again. You say it's that much styrofoam for one bean. So then you write that down and you say 1 bean equals a handful of styrofoam. And then you just keep on trying other stuff. We got these, ¿cómo se dice? Chips. Chorritos. To put on one side, you can figure out how many beans that's equal to, or how many pennies, or how many of those it takes to get 1 penny. You know, you just compare all different things. So you're weighing them. That's basically what this is comparing the amount of force that gravity puts on this side to the amount of force that gravity puts on that side. Because weight is a force. Okay, so then at some point you want to say, oh, I would like to quantize. I would like to know exactly how much it weighs. Well, now you've got your syringe and your water here. And so you can take the syringe and pull out exactly, no it doesn't, you don't have to do it there. You could start here at exactly 10 and subtract, but it's easier just to squirt it in there and say, well, it's about this much water is the same as the frito. And then, how much water was that? Well, you could suck it out again, suck it all out into the syringe, and then just like the nurses do, you've seen the nurses, you go tap out on the side, get all the air out of there, all the air up to the top, and squeeze it till it starts to come out. Then you can see it's exactly 1.246. 1.6 what? Well, they're milliliters. If you look on here, it says milliliters, which is the same as a cubic centimeter, which is the same as a gram of water. That's the connection between all these things. A cubic centimeter is a milliliter, and if you're talking about water, that's 1 gram. So you can read the grams, the mass of these things, straight off of the syringe. And these lines, if you look at them carefully, there's only 5 lines between one number and the next. So each line is 0.2. So if you go 1, right now I've got 1 and 3 little lines, that's 1.6. That's 1.6 grams that this thing here weighs. All right? Now that's mass, but in 5th grade, you don't have to nail down the distinction between mass and weight. You can mention it, but you don't have to get them to actually understand that. So I'm going to say 1 chorrito is equal to 1.6 grams. Okay, then you could do something else. You could take a big piece of styrofoam, or 5 beans, or 1 bean. The bigger it is, the easier it is to weigh, because then you've always got a little bit of stuff left in there when you try to suck it out. So it's not precise, but it's not bad. Okay, so that's the first part. Now the second part, so we got also paper. You can weigh paper. And one thing you could do is take some paper and stick it in there very smoothly like this, and find out how much it weighs with water. Or you don't even have to find out how much it weighs to do this one. You could put this in here till it's level, till it's perfectly level, and then drop. It's a bit too much, but más o menos. And then you could say, all right, now I'm going to change the paper. I'm going to squat this paper all up. You think that's going to change the mass? Maybe that's going to change the weight. Pop it back in there and level it back out again and see what happens. Oh, it did change the weight. Oh, now that's interesting. That means we should publish, because it's not supposed to change the weight. According to the theory, It doesn't matter if the paper is smashed up or not. Wonder what happened there. Let me unfold it and see if that helps. It got lighter for some reason. It's not going down as much. Put it big like this, stick it back in there, and level it out again. Well, I'm gonna try it again. I like this to work on the video. Dump the water out and hang it up, and this time I'm gonna make sure it's swinging freely. Swinging very freely. And I'll put some water in there. All the way. Oh, that's too much. Take some out again. Some water in. A little bit more. Move this back and forth. Yeah, just kind of wiggle it back and forth till it's moving really smooth. Okay, that's almost smooth. I'll take a little bit out. Put it mostly back in. And 2 more drops. Wiggle, wiggle, wiggle. Okay, there it is. Okay, now I'm gonna take it and smash it up. Stick it back in there. And it's the same. That's what's supposed to happen. Yeah, you gotta look at the little place where it's hanging and make sure nothing is stuck there, so it's free to move back and forth. Okay, so that's one. Now here's a very interesting one. If you take the bottle and you pour the bottle out, and instead of water, you put some vinegar in there. This thing here is full of vinegar. So you dump a little bit of vinegar in there. Not very much, because this scale can't handle very much. You should take like that much vinegar, and then you put the lid on again, so it doesn't dump. And put that, oh no, so then you also get some baking soda. And that's in this bag over here, baking soda. And then you get the palito, and you take some baking soda, and you put some, doesn't matter how much, maybe I'm gonna put 2 of these things, 2 of these palitos of baking soda on the paper. Now, I gotta try to put all of this into the cup. So I'm gonna fold this up like a little burrito of baking soda and stick it in a cup. And then I'm gonna put this in the cup too. And now I gotta balance it on the other side. So now you can use water or coins or pennies or whatever, or a combination of stuff, until you get it balanced on the other side. Okay. It's kind of heavy, that little bottle. Oh, that was too much. Let's take him out. Okay, I'll take one bean out. Kids will do that better because they got smaller hands. One more bean. And there it is. So that's the vinegar and the baking soda is that much. It's equal to that. Okay, so now I'm gonna grab this thing and I'm gonna I'm gonna rest it over here so it doesn't fall down too far. Somebody could hold that. And then I'm gonna put the baking soda into the vinegar. Okay, that sounds exciting, huh? Everybody knows that's supposed to make a chemical reaction. Okay, let's do it. So you squeeze this thing up like this. You chuck it in here. And then I got the lid. I'm gonna put the lid on real quick so I don't lose anything if it happens to happen during chemical reaction. Then I kind of shake it up. You can kind of see something happening in there. Oh, bubbling, bubbling, and actually the bottle is getting really tight because there's some gas coming out of there. Happens to be carbon dioxide. And now I'm going to put it back in there. This is after the chemical reaction took place. And the big question is, whoops. The big question is, did it change the mass? I didn't lose any beans, so this should still work. Hang it back over here. It fell off of my nail. Some of these holes are a little bit too big and the nail goes through. And this one back over here. And my bottle is tight. It shouldn't matter if it waited a while. Now that reaction has taken place. I put that cup on wrong. Now I let it go and it's exactly the same. Well, that's according to theory. According to theory, nothing came out of the bottle. We didn't lose anything. All the things before the reaction went in and they're still in there. So even though the reaction took place, the mass is the same. That's one of the key points in the NGSS. So that's why we did this, so kids can see that. But now the really interesting thing is this. Every kid is gonna wanna open that bottle. Okay, let's open a bottle. Put this over here again. And your way to open it is as fast as you can. Woo! It goes flying across the room, all right? And some stuff came out of the bottle. I don't know if you saw it, but I could smell it. Some stuff came out of the bottle. Let's weigh it one more time. All right, I have to put it in right side up. Hopefully it doesn't tip over. And let it go. And oh my gosh, look at the difference. Now this one's much lighter because it lost something. It lost something invisible. You couldn't see it coming out, but I could smell it coming out. And we could see it push that cap off. So that's all that gas, it lost it, and you can see that loss of gas. As long as you keep it all together, it weighs the same. That's called conservation of mass. All right, there's one more you can do. It's also in the standards. It's not very interesting though. You do the same sort of thing, only this time you get some salt. You put some salt in there, and then you put some water in there, and you weigh it. You find out how much it weighs and get it almost equal, and then you mix the salt into the water. So you stir the salt in, you make it dissolve in the water, and then you weigh it again. You see it, that changed the weight. And according to theory, that doesn't change the weight either. That's just a mixture. So there's all these things you can do. You could change the size or shape of it by squeezing it, smashing it. You can make a chemical reaction happen, or you can make one enter into a solution, and then you can check to see what the weight is afterwards. And you should write it all down in your little science notebook. I think that's it.